Welcome everybody. Today we'd like to do an application using the derivative. This application will be to find the equation of a tangent line. So let us start with the typical given information. We have some type of curve. So let's say we have 3x squared plus 4x minus 10. And let's say we have some particular x value at x equals, just for fun, -1. So what we have is we have this curve here. We should all know what this curve is because of good old algebra skills. X squared, parabola. Positive number in front of the x squared, upright parabola. At this point, -1, I can imagine at this point on the parabola, there is this tangent line. And I'm trying to find the equation of that tangent line. What is the exact name of that tangent line at this value x equals -1? Well, to find the equation of a tangent line, you need two things. Because the equation of, first of all, the equation of any line is y equals mx plus b. So if you give me the m, the slope, and the b, the y-intercept, you found your equation of any line. Now this is a tangent line, so it has a very, very special slope. The slope of the tangent line, ding, 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 is the derivative. So what we have is step A, I want to find the slope. To find the slope, m is step A, I'm going to take the derivative. Well, the good news, you have your derivative rules now. This is a pretty nice, simple one, just all good old power rules. Derivative of 3x squared is 6x. The derivative of 4x is 4. And the derivative of 10 is 0. So there's our derivative at any point. It's our derivative function. Well, I want a specific derivative. I want a specific slope. That's at the value of -1. So what I can say is when I evaluate the derivative at 1, i.e., when I evaluate at -1, that's the point, it's -1. When I plug it in, careful with your math, guys, plug in -1, 6 times -1, -6, plus 4 is -2. So this is the slope I am currently looking for, -2. Excellent. So that means in part B, I already know the slope of my tangent line is -2x, but I don't know the y-intercept. Okay, to find the y-intercept, well, if they gave me the y-intercept, that'd be nice. I can plug it in now. Typically, they don't. They usually give me a point to evaluate at. They did give me x is -1. If I had a point, an actual point, this problem would be pretty easy to do. They have given me a point, we just don't know yet how to get it. I hope you do soon. If x is -1, for every x, there should be a y value that pairs to it. That's really what a function does, is for every x, I can pair a y value to it. So I'm going to take this x and actually plug it in. All right? I'm going to take this x and plug it into the function. Importantly, if you plug the x into the derivative, you get the slope. If you plug the x into the function, you get the y. You gotta always get those straight. Almost flashcard that. X into the function, y. X into the derivative, slope. And just flashcard that. So we plug in -1. Be careful with the algebra, guys. -1 squared is 1. So that's 3. -1 times 4 is -4. That's -14. 3 minus 14, I believe, is -11. I'm going to just check that one more time. -1 in parentheses. All right, when you plug it into your TI, if you're going to use your TI, you better put that in parentheses. Whenever you plug a negative into an x, you should put it in parentheses if you're going to use your TI calculator. Be careful. So this is 3 minus 4, -1, minus 10 is -11. Awesome point. That allows me to evaluate this function. The -11 goes in, the -1 goes in for x, because that's what they are. And if this point is on this curve, then this point, and it's tangent to this line, then this point must be on the line, okay? This x is on this curve, this point is on this curve. For it to be on the line when I plug it in, it must work too. And that's what I'm banking on right now. When I plug this point in, I need it to not only satisfy this equation, but I need it to satisfy this equation. So when I plugged it in and solve, let's do some quick algebra there. That's a 2, careful, right? 2 negatives. And then subtract it over, allow me to run out of board space here. My b is negative 13. Subtract the 2 over, gives me negative 13. So my final answer that I'm looking for, ding, 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 is the tangent line, YT I'll call it, is negative 2x minus 13. And that's what I'm looking for, the tangent line. I want to draw it in a second just so we can get an idea of what we're doing here. But how do you get the tangent line? This is what I do all the time. Give me the function. The derivative is the slope. All right, the derivative is the slope of the tangent line, a very special line, okay? The derivative is the slope of the tangent line. I'm looking for the tangent line. Here's my x, I plug it in, I get the very particular slope I'm looking for, negative 2. All right, I need a point, because what happens is this point will be on this curve, and this point will be on this line. That's what tangent means. They're going to touch at that point. This curve and this line, my answer now, touch at negative 1, negative 11. Let's check it out. Plug in negative 1, you get negative 11. Plug in negative 1, you get negative 11. They're equal. So that obviously they meet at that point. Excellent. So just to summarize, what I did here was give myself a parabola. So here's my parabola. I'm not sure which side negative 1 is, to be honest, without plotting it. But let's say negative 1 is over here. I lost my point. I think it was negative 1, 11, right? Or negative 1, negative 11. There's my point. That point on the parabola, the tangent line is right there, my YT. There's my tangent line. I want the name of that blue line. I just found it. The name of the tangent line, a line tangent to the point, or tangent to the curve at that point. Let me be very clear, right? So here's my curve, parabola. I want the tangent line that touches this curve at this point. I found it by utilizing the derivative. The derivative is a very vital tool for finding tangent lines. Why are tangent lines important? Please look them up. The best thing I can say is they're great forecasters in a small area. They're great predictors in a small area. In business, when interest rates don't change that much, so interest rates and bank loans, bank rates, they don't change much. So instead of using a nasty equation, we often use the tangent line because with interest rates, they don't change much. So having this small little area, the blue and the black, are relatively the same, and it's a good predictor. Thank you for watching this video. I hope you enjoy others.